Our next presentation is from Kevin Salvidge of Leader Instruments, and he's going to be talking about QC monitoring and maintenance for IP-based environments. So take it away, Mr. Salvidge.
Yes, thank you very much, and thank you once again, Ames, for allowing us to speak to you at the IP Showcase at NAB 2023. So let's start off with a disclaimer. The following feature will feature real-life events, but we're not going to name and shame anybody because this is the only way we learn how this stuff works, is real-life practical experiences. So, let's start at the beginning. Any system, for it to work reliably, has to have a reference source. And unlike Black and Burst and tri-level sync in the SDI world, PTP comes with a number of parameters that, if incorrectly configured, can result in unexpected and unpleasant effects for your IP operations. So let's take a look. As most of you will be aware, the selection of the Grand Master, the ultimate source for reference within a PTP network, is elected by a process called the best master clock algorithm. And there are a number of parameters that allow you to design a PTP network so that you can control the failover, so that you will go through the devices that you expect. And we have tools such as Priority 1, which you can manually set. We then have tools like the clock class, clock accuracy, and clock variance. Now, you can affect these, but typically this is controlled by the manufacturer of the equipment that you're using as your PTP generator. So the chipset they've used, the oscillators, all of that will define these parameters. The control you have over it is whether you decide to connect it to a GPS antenna or run on an internal reference. That's your choice. And then we have Priority 2, which, like Priority 1, gives us the ability to control the failover routes. And you'll see these if you go into the settings of any of your sync pulse generators that have PTP. You'll have the ability to set Priority 1 and Priority 2. So that's something that your network design architects will put together and design a system and talk about how it's going to fail over. So let's have a look at the best master clock algorithm. It basically works by electing the Grand Master. So when devices are switched on, they issue a series of announce messages that go across the 2110 network. And while they're doing that, they're then polling each other to find out which device has the highest accuracy. And once one has been selected, we then have the Grand Master. And as you can see, the reason why PTP Grand Master A has been selected here is because of Priority 2. Priority 1, the clock class, are both the same. Priority 2 is 2 on the second device. So the Grand Master will be A. So that's a very simple system. It's talking about how PTP is generated. Within the 2110 world, it gets a lot more complicated. So here is a high-level drawing of a leaf spine architecture with red and blue redundancy and as you can see, they are completely air-gapped. The only connection between the red and the blue is the VLAN that I've put at the top between the distribution layer switches. So now, as part of the design of your PTP network, you've got to look at an architecture so that should GMA fail here, you want number 2 to be the backup. So you'll see within PTP design, priority 1 used sort of as you cascade down. So devices that create PTP, our advisory is make sure they're clock class 1. Then the switches that sit on the distribution layer, make them clock class 10. Then when you move down to the media spine, you make them 20. And finally, when you get down to the leaf, you make them 100. That way, you're using priority 1 to control how the failover takes place. The other area that can cause confusion is PTP domains. So before we had the world of 2110, we had audio over video, AES67. And that world uses PTP domain 0. There is a lot of audio over IP out there. They're not going to change. So unless your system has AES67, don't use domain 0. The next piece, and go and look at IP systems out there and you will see them set for this, is domain 127. We highly recommend that you do not use domain 127. The reason being is that if you plug a new device onto your network and its priorities and its clock class are of such a setup, it could become the grandmaster on your network. And that could then have serious repercussions for every device connected on the network. So, we personally, if you've seen any of my presentations on other subjects, you'll see I use domain 44. It sits in the middle, doesn't really upset anybody. And I've not had any problems using that one yet. And again, like with priority 1, the domains are set within the SPG that you're using as a grandmaster. You'll also notice that I said there are 2 domains. In the world of Ethernet, I can have 2 different timing domains going over the same cable. So you'll find most sync pulse generators have the ability to output 2 PTP domains. So you'll see one set for 0 for your AES67, and then you'll see one set for your video. So the great thing is that you've got your PTP reference coming from the same device. Whether it's video or audio, you've got it coming from the same device. So should that lose a GPS connection, both will remain locked to each other because they'll have the same internal oscillator. And that moves us on to the next bit of animation. What happens when this system that you've designed starts to misbehave? One of the things I would recommend that you look very closely at are the announce messages and the timeout intervals you've got set on those announce messages. Because if it's set up incorrectly, one of the leader devices can become the grandmaster purely because it thinks that the grandmaster that was previously the grandmaster has gone offline because it's not acknowledged its response. So you'll find within SMPTE 2110, it does actually specify what the announced message timeout interval should be. And I'd recommend that you check this on all devices in the network that are involved with PTP. So your generators, your switches, check them, because that can send your best master clock algorithm off on a chase that ends up with a device you didn't expect becoming the Grand Master. And again, you'll find this within the sync pulse generator setup menus. And there are two sets of parameters, one for SMPTE 2059 and a second one for AES 67. So as I said, this runs continuously, so the leader capable devices are constantly on the lookout for a possible loss of Grandmaster. For this reason, you want the network timeout detection to be longer than the timeout interval of the best master clock, Grandmaster or leader. If they don't, then as you're going to see here, the leader capable device will keep jumping in, and because of the way the best master clock algorithm works, it will go back again, and then you're going to have a timing reference network that's going to be unreliable. So to summarize, in an air-gapped network, the only connection between the networks is the PTP communication between the two grandmasters and the leader. Each leaf connects to each spine on its own network, and each southbound leaf port is a boundary clock. So you need more nodes, you add more leaves. If you need more bandwidth on your system, you add more spines. To ensure that the best master clock election takes place at the distribution layer, that's what you want to happen. And what you'll find is, within the various switch manufacturers, they have various command line prompts that allow you to stop devices downstream popping up and becoming the Grandmaster. So by default, these switches, when you buy them, will come with this switched off, because anybody who's done anything with 2110 will find that you buy a switch and basically all of the good stuff that we need is switched off. And you have to go through and switch it on for each switch. And as you can see here, this is a small system, and there's already about 15 to 20 points I've got to go in and set up. But that's what they do. If you don't do this, you can end up with some very strange and unexpected results. And how do these results appear? Well, with test and measurement products, providing they're set up to be logging this type of information, you can see here in the event log, it's flagged there's been a change of Grandmaster. And the great thing with the Grandmaster MAC address is that you can very quickly Google that and find out who manufactured it. Mellanox, Cisco, Arista. So at least you've got a clue who's jumped in as the Grandmaster. And as you can see from this, the line at the top, 09, 0009 OD, is leader. That's our assigned MAC address. And again over here, make sure that that reference is enabled, and then the event log will register it. So that's one part of the challenge. The next part is that most of you will probably still have some SDI video floating around. So you will still have a black and burst reference, tri-level sync, etc. So black and burst audio always went through an emergency changeover unit and then out to the distribution amplifiers. In the world of 2110, PTP goes directly onto your 2110 networks. There's no changeover units. This gives you an opportunity now that you don't have to have the PTP generators all from the same manufacturer. You could have a mixture. Therefore, you're not now beholden, if there's suddenly an emergency software update or some fix, to have to plan your whole facility. You could look at it and go, I just need to fix manufacturer A, but I know I've got manufacturer B and C running perfectly in the background. So it builds a level of resilience in. And we're seeing a number of customers now who in the SDI world would have brought the solution from a single vendor, now buying from different manufacturers so that they're not sort of held up and tied into one particular product. So here we have the Grandmaster has been selected. The traditional SDI and Black and Burst references are going to the changeover unit. And then I lose GPS. I've lost the reference. That has now affected the clock classes within the system, and it means that the backup has taken over. But my analog Black and Burst tri-level sync is still coming off of the old one. So what we've recommend, and a number of customers have deployed this, is to use, because you've got an SNMP control system monitoring the facility, with the changeover products we have the ability that should it see a change in the Grandmaster to issue a toggle command, which means it will switch. So now, with that enabled, when I lose my Grandmaster, the backup takes over for PTP and it's switched my sources. So now I can decommission this unit and start carrying out the maintenance work on it. Ancillary data. In many ways, ancillary data is actually more important than the pictures. And over the years, the SDI ancillary data has kind of become the home for lots of things. Some are intrinsic to the video signal. They're line accurate, their requirement, closed captions, audio. Some are kind of independent essences that tell us about the video. It's color imagery, it's HDR transfer characteristic. And there are some that have been put in there because it was a good place to put it and we can't really remember why we did it, but it's there, which now means as we start working with these IP systems, we've got to find a way of identifying them and understanding how we apply them to a 2110 suite of signals. So the video payload ID goes under the SMPTE title of ST352 and is carried within the ancillary data space to assist the device in quickly decoding the video. But as we all know, in the world of 2110-20, the transport stream is of uncompressed active video. There's no blanking. The ancillary data manages this part in SMPTE 2110-40. So what you now do is you now need tools that present that information to us. And here we have an example of the SDI output. If you're an SDI engineer, you're going to look at that and go, I understand that completely. It's 3G, level A, it's progressive, standard dynamic range, 709 color space. So what we've done at Leader is we've taken that information out of the -40 stream and presented it in exactly the same format. So any SDI engineer can look at that and go, it's wrong color space, that's why it's wrong. And the same within our fabrics range of products as well. We have that information displayed in a format that anybody who's been brought up and trained on SDI video will understand. But now we have a new challenge. To assist in the control of switching of IP multicast flows within broadcast facilities, broadcasters using NMOS orchestration systems to configure IP receivers. And those receivers receive information by what's called a session description protocol file. And the SDP does not deliver any media streams itself, but is used between endpoints to negotiate on network metrics, media types, and other associated properties. So if you go into a system and look at a session description protocol file, you will find there will be a -20 version, a -30 for your audio, and a -40 for your ancillary data. And if you look at it, once you get used to it, you can very quickly start to pick out the information within it. Its source address, its multicast, its video format, and information about that PTP Grandmaster that we were talking about right at the beginning of the show. We also have tools within our test and measurement products that can tell you that the receiving device has actually received this information, because it could be that actually you haven't got it at all. It's not been sent to you, or you're looking in the wrong place. And also we can highlight being able to analyze if there are any errors occur within the SDP files. Because if you're using a -7 operation, you'll have a primary path and a backup, and really the session description protocol file should be very similar, certainly about the video essence that you're looking at. So your test and measurement products have to have a suite of tools that allow you to see this. Here's an audio, ancillary data, and on the leader products, you can actually export this via a USB key, so you can take it away and analyze it, because these can get quite big and quite complicated the larger the systems. So in a true hybrid world, you'll have your SDI payload, you'll have your IP payload, and you need a test and measurement tool that's going to allow you to compare your SDI and IP. So as we can see on this example here, my SDI on the left says it's got a progressive transport structure, yet on the right it says it's interlaced. And great examples of how this can show up. And if you're here at the show, come and see us on the leader stand. We're actually demonstrating this, where the SDI video has the closed captions. Where are they on the IP version? Same again here. Picture, waveform, picture, no subtitles or closed captions. Same can happen with audio. You can end up with some of your audio channels missing, because the session description protocol file might not give you all the information. So they're a great tool for understanding what's going on and where to start to debug and fault find on your IP networks. The final piece we'll talk about is IP to SDI gateways. And test and measurement products have always traditionally been used as gateway products. And now with the introduction of IP, they're continuing to fulfill this role. So here we have an example of a -7 network with a primary and backup. It's coming into a waveform monitor. It's turned into SDI video. And on the leader products, we have the ability to specify what VPID information should be inserted into that SDI stream. Whether it's come from the -40, it's come from your session description protocol file, or you've manually set it up. So now this means that when you select a source, the device downstream will switch and behave exactly as it did in SDI, because it's got the information about its payload, its transfer characteristics, all that information that in the world of SDI video we take for granted. And the last piece, audio to video synchronization, lip sync. Thought we got away with this, hadn't we? Thought we'd consigned this one to the trash can of life. Oh, it's back. So to understand what's going on, your PTP Grandmaster is used, and every device within the 2110 network, when packets leave it, get an RTP timestamp. And that's how 2110 works. The video, audio, and ancillary data are realigned because they all have the same RTP timestamp. Good. But what happens if you have a system? So here we have a camera going into a switch. We get an RTP timestamp. That then goes through a vision mixer and an audio mixer. We get an RTP timestamp. Everything's synchronized. Life is good. So we know exactly what that propagation delay is. But now, we're in a world where we're probably going to acquire content in 4K, wide color gamut, HDR. But we could well be also delivering HD standard dynamic range. That means somewhere there's going to be an HDR to SDR conversion. Somewhere there's going to be a UHD to HD conversion. Each of those processes gets a new RTP timestamp. There is no SDR to HDR conversion for audio. There is no 4K to HD conversion for audio. So that goes straight through. And lo and behold, your audio is now not synchronized with your video. So we need tools that allow us to identify what that propagation delay is. And strangely enough, the traditional lip sync test patterns are as relevant today if they're generated in IP, because they can be sent out through a system. You've got your audio bars and phase meter to confirm it's the audio you expect. And then we have a graph that will show you how much the audio leads or lags. It's a very simple graphic, but as you can see, it's telling me in milliseconds or frames against my audio channels what the delay is. So this means if I go through here, I send that pattern out, I receive it here, and it means I know exactly what that propagation delay is. So I could make that measurement here. So if I'm just doing a conversion from UHD to HD, but it's still HDR, that's the delay I need to add. If I'm adding UHD to HD conversion, I drop down again. So that concludes my session today. If you'd like a copy of this presentation, it is now available. All we do is need your details. Obviously, if you're here at the show, Leader and Fabrics, we're in the Central Hall, C429, where everything I've spoken about and lots more is on display. And finally, these are my contact details, so if anything springs to mind after you've seen this show, contact me, and I'll probably respond saying, that's a good question, haven't seen that before. I wonder why that happened, and let's find out. But thank you for your time, and I'll be available after this presentation for any questions.